Hello guys, thank you for joining me today. Today we're going to go through a tutorial on how to do the chain rule in differentiation. This can be a difficult topic for some people, so I just wanted to take you through this. So first thing we want to note is that the formula for this is dy dx is equal to du dx multiplied by dy du. But without further context, this rule is a little bit confusing for some people. So where exactly does the u come from? Basically, the idea of the chain rule is that we are looking at a function to the power of 7. But instead of thinking of it as a whole function, we're going to break it down a little bit and consider this as just being a term. So if we write u is equal to 2x cubed minus 5, then this gives us the equation y is equal to u to the power of 7. And now you can see where we get the dy du term from, because if we differentiate this equation here with respect to u, then we get dy du is equal to 7u to the power of 6. And similarly for the du dx equation, if we take this one down here and we differentiate u with respect to x, then we get du dx is equal to 6x squared, and that minus 5 just drops to nothing. So then to solve for dy dx, we're simply going to do du dx, which is 6x squared, and dy du, which is 7u to the power of 6. We're going to multiply those two terms together. But of course, we want our final answer to be in terms of x. So we're going to take this u value now, and we're going to substitute the value of it back into the equation, which is 2x cubed minus 5. So we're going to say dy dx is equal to 6x squared multiplied by 7 2x cubed. Oh, my pen wrote that a bit weird. To the power of 6. Let's write that bit weird too. Lovely. And then we can just neaten this up a little bit, and we're left with 42x squared multiplied by 2x cubed minus 5 to the power of 6. And that's it for chain rule differentiation. Once you get a little bit more confident with it, it's not necessary to do this whole step. The idea is that we are taking the derivative of the inside function here, and then we're going to multiply it by the derivative of the entire function. So let's create a different question and try and practice this, just to improve your proficiency when it comes to the actual exam. This time, y is equal to, say, 4x to the 4 minus 1 to the power of 5. So the way we're going to solve this is we're going to say dy dx is equal to the derivative of the inside function, which we can calculate in our heads. We're going to bring down the 4 and reduce the power by 1, and the 1 drops off. So it's 16x cubed. And then it's multiplied by the entire function, which is, multiplied by the derivative of the entire function. So if we just ignore this bracket and just consider it as bringing down the power and reducing the power by 1, then it becomes 4x to the 4 minus 1 to the power of 4. And we'll tidy that up to give you 80x cubed 4x to the 4 minus 1 to the power of 4. We'll do that one more time. We'll say y is equal to 2x to the 5 minus 9 to the power of 11. Why not? Throw in some big numbers. So we're going to multiply. First, we're going to find the derivative of the inside of the function, which happens to be 10x to the 4. And then we're going to multiply it by the derivative of the outside of the function, which is going to be 11 2x to the 5 minus 9 to the power of 10. And then if we tidy that up, we get 110 x to the 4 multiplied by 2x5 minus 9 to the power of 10. And that's how to do chain rule differentiation. I'm going to give you one question to end this video and give you a little chance to try this yourself. So we're going to say y is equal to 3x to the 6 minus 8 to the power of 4. And see if you can do it yourself. Use chain rule differentiation to find the value of the y dx.